Hi, everybody. It's Monique Morton, Mathematics Director for AdvanceKentucky, and I'm here with my second hangout for AP Calculus based on the questions that some people have given me through Twitter. So if you want to still ask me questions, you still can. You can tweet using the hashtag AskMoniqueKY, and that'll get me live, and I'll answer your questions. So right now I'm going to go ahead and I'm going to start using some questions that some of the other people have given me and do some examples in trying to answer them. So first, let's start with a question from Danielle. So Danielle asks, what's the relationship between increasing and decreasing behavior of f and the sign of f? Well, the question is, the answer to the question is the following. If the derivative is positive, then we know that the graph is increasing. And if the derivative is negative, then we know that the graph is decreasing. For example, when you look at your graph's values, and your graph is doing something like this. Sorry about that. When your graph is increasing and your function is, if the derivative is positive, the graph of f is increasing, and if the derivative is negative, the graph of f is decreasing. The point I'm also trying to make is the following. The converse of these statements aren't true, because when you think of stationary points like the one that happens at x on the graph of f equals x cubed at x equals 0, even though that function is technically increasing for all real values of x, the derivative at x equals 0 is not positive. So you have to be careful if you're trying to go the other way around. This is something that we hope folks got to early in the school year. Mike asked, how do you approximate a value using the Taylor series? Well, this is a BC question, so AB students, I'm going to need you to be a little patient for a few minutes. Mike, when you start out, the Taylor series in general is really an infinite series. It has an infinite number of terms. And for a certain number of values in a particular interval, that is the interval of convergence, this Taylor series is going to fit that original function. So we center it around a value we call, let's just call it C for now. And so in general, our Taylor series for a function f centered about x equals c is given by what you see here on the slide. If I just take a few values and not the entire thing, if I'm just looking at, oops, wrong way, sorry about that. If I'm just looking at, say, the first 3 values here, then I'm looking at a third partial sum. Third partial sum because I have the first 1, 2, 3 terms. I'm also looking at a polynomial now because it has a finite number of terms, and it's a second degree polynomial because the highest power of x would be 2. I can use this second degree Taylor polynomial to approximate a different value of x for the function as long as it's some number that's reasonably close to c. If I want to approximate it using a third degree Taylor polynomial, I just add one more term. So I'd end up with more than one term. So if it's third degree, I'll end up with 4 terms. If it's fifth degree, I'd end up with 5 terms. And I'm using the first so many terms to approximate the actual function value. Let's look at an example. So this is from the actual AP exam the BC question number 6 from 2008, and we're only going to look at part of it. We have a logistic differential equation, dy dt equals y over 8 times 6 minus y. Y equals f of t is the solution to the equation, and we're giving the initial value f of 0 is equal to 8. In part C of this question, the students were asked to write a second-degree Taylor polynomial for f about t equals 0, and then use it to approximate f of 1. So this is exactly the kind of question I think Mike was asking about. So what we're going to do is we're going to start out with the fact that we know that that differential equation was dy dt equals 1/8, well actually y over 8 times 6 minus y. Since they want me to do a second-degree Taylor polynomial, I suggest that you start writing down the general expression. Since it's second degree, you're going to need 3 terms. The first term, which is constant, plus the second term, plus the third term. Notice that since c is 0, I'm evaluating the function, the first derivative and the second derivative at x equals 0. And my x's are x minus 0, so that's why I'm just writing x. So I'm going to need f of 0, which they gave me, that's 8. I'm going to need f prime of 0. So I'm going to plug 8 everywhere I see y into this equation. So I get 1 times 6 minus 8, or -2. For the second derivative, which they didn't give me, I'm going to have to use implicit differentiation. So for the AB students out here, I'm going to go through the implicit differentiation because that's applicable to you too. You too need to know how to do implicit differentiation. So to find the second derivative, given that first derivative at the top of my page, I'm just going to go ahead and use the product rule. 1/8 dy dt times 6 minus y, taking the derivative of the first, plus y over 8 negative dy dt, taking the derivative of the second. Notice I know what dy dt is at the point that I want, so I can just start plugging some stuff in, right? At the point 0.8, the second derivative is going to be 1/8 of -2 times -2, because that's 6 minus 8, plus 1 times the opposite of -2, which is +2. So altogether, my slope is going to be 1/2 plus 2, or 5/2 x squared. So here is my Taylor polynomial right here. To use it to approximate f of 1, I'm going to substitute 1 in for x in this expression. So, sorry about that. So, 8 minus 2 times 1 plus 5/2 times 1, because 1 squared is 1. And I end up with 6 plus 5/2, or 17/2. So that's going to take us to the first part of our questions. And I'm going to now move on to some other questions based on what people had sent me over the last few things at Twinner. Once again, if you still have questions, it's not too late to send them. You can send them to me, tweet Monique _Morton or use the hashtag #AskMoniqueKY to ask more questions. So now I'm going to go back to another AB question. And all the AB questions are also on the BC exam, so the BC students can watch too. And the next question I got comes from Erica. And what Erica had asked was, can I explain the extreme value theorem? Yes, I can explain the extreme value theorem. Let me start with saying a statement of the extreme value theorem. If you have some function and it's continuous on a closed interval, then that function must have a max and it must have a min. Don't overthink the extreme value theorem. It's just an existence theorem. Basically, if you have a function and there are no holes, breaks, or asymptotes, I don't care where it looks like, as long as it's continuous on some interval from A to B, it has to have a max and it has to have a min. That max and min might be at the endpoints. It can be in between. There can be more than one. But as long as that function is continuous, it must have both a maximum and a minimum value. I'd suggest try to come up with a counterexample. Can you draw something that is continuous on a closed interval and doesn't have a maximum and a minimum? And just for that student who says, well, what about the function that's constant? Let me remind you what we mean by max and min, right? If f of c is a max, then it's greater than or equal to every value on the interval. If it's a min, then it's less than or equal to every value on the interval. So if your function goes straight across like this, it does have a max and a min. It's just that the max and the min are the same number. Let's move on to another question, which is actually a BC question, but it's not going to take very long for me to answer it. I know the conditions for the use of the integral test, but how do I use this integral test to determine divergence? Well, the short answer is you don't. Okay? The integral test is a test for convergence. It can't tell you whether it actually diverges or not. It can only tell you whether it definitely converges. The only test that would allow you to say whether a function actually diverges is the nth term test. It's the only test that you need to know, at least, that is actually a test for divergence. So all of the other tests that you have to know, the integral test, the alternating series test, the geometric series test, the p-series test, and a comparison test are all tests for convergence. If the conditions are met, then you know that this series converges. If the conditions are not met, then you don't know anything. You have to use a different test. The only test that tells you that a function diverges is the nth term test, and it's just the opposite. It can only tell you that it definitely diverges. It can't tell you whether it actually converges or not. So what I would say to students is when you're faced with a series question on the BC exam and you have to determine convergence or divergence, you always do the nth term test first, right? It's easy to do and you can do it by inspection. Look at the limit as n goes to infinity of the nth term. If it doesn't go to 0, you know the series diverges, you're done. If it does go to 0, then you know it might converge, and now you need to try one of the convergence tests and see which one best fits. I'm going to go on now and try to go on to another question. The next question I'm going to go to Mike asked, how do I find a region that forms the base of a solid whose cross sections are perpendicular to the y-axis? Now I'm going to stick a word in here because I think what you're asking me, Mike, is how do I find the volume of a region that form, and you want to find the volume of the solid, not the region. And if I'm wrong, well, tweet me and I'll correct myself, but I assume this is what you wanted to ask me. So I think the best way to go over this one is with an example. So here's my example. R is a region enclosed by the circle with the equation x squared plus y squared equals 49. The region R is the base of a solid. For this solid, cross sections perpendicular to the y-axis or squares. Notice I said y-axis because you asked for that. Find the volume of the solid. Okay. So let's start with the base. My circle didn't come out very clear, but you can see the outline of it. So what's happening here is you've got squares that if you pretend that my screen is the base, then the squares are coming at you from the screen, directly out of the screen. So it's three-dimensional. One side is coming across like this, perpendicular to the y-axis. So this is going to be one side. It's really skinny, but one side of one cross section, right? Now this rectangle that I just drew is so skinny that even though technically the two sides are different lengths, they're practically the same length. So if we know that this is the circle x squared plus y squared is equal to 49, and my slices are perpendicular to the y-axis, I'm going to call this point x1 comma y, and I'm going to call this point over here x2 comma y, because these 2 points have the same y coordinates but different x coordinates. So over on this side here, I want you to think about what that cross section looks like. It's got a square base and a little bit of thickness. This is the base. It's a square, right? So each side, S-I-D-E, of the square is the same length, right? This length, the length of this line segment, is the length of the side. This little bit of thickness right here, that little bit of thickness is a little bit of change. If this was going on here, it'd be how thick this rectangle is up here. That's a little bit of change in y because it's vertical. So I'm going to say that the height or the thickness is dy. Now let's go back to geometry, way back to geometry. How do you find the volume of a solid whose bases are squares and whose height h is whatever? Well, to find the volume of any figure like this, you need the area of the base times the height. In this case, the base is the square, and to find the area, you're going to take the length of a side and square it, and in the height is dy. The hard part about these problems is setting it up, right? So let's think about this way. Trying to make it go to the next page and it doesn't want to go. Hold on a second. Well, I seem to be stuck. Anyway, so the length of the side is going to be x1 minus x2 for the difference between the x coordinates. We're going to square them to find the area. multiply it by the thickness, and that's going to give us the volume of one of the cross sections. The total volume is going to be the definite integral from -7 to 7 of x1 minus x2. So to get x1 minus x2, stuck. It won't go to the next page. Oh well. How about this? There is no next page. Sorry about that. So to get x1 minus x2, remember we knew that x squared plus y squared is equal to 49. If I solve this for x, then we actually have two solutions, plus or minus the square root of 49 minus y squared. So that really means that x1 minus x2 is the positive square root minus the negative square root. So that's equal to 2 times the square root of 49 minus y squared. In other words, the volume that we're looking for is a definite integral from -7 to 7 of 2 times the square root of 49 minus y squared, all squared, dy. I'm going to assume that you can probably finish the point from this point forward and move on to another problem. It's an important thing to note that these types of problems will show up. Sometimes if they show up on multiple choice, you don't actually have to solve the problem. You just have to stop where I did and be able to set up the problem. It took me a while to get beyond my technology issues, but I hope you followed along that this is really reaching back to the geometry. If you go back to the original geometry of how do I find the volume of a solid whose bases are squares or semicircles or circles or right triangles or equilateral triangles or whatever they are. If you can figure out how to find the area of that one piece and think of those as bases of a solid where the height is either dx or dy depending on which way the side is perpendicular to, then the problem should become an easy one. Solve the smaller problem first, add up all the smaller ones, and get the entire volume. So it's time to move on to another set of questions. And I think this is probably the last question that I have, yes. And this one is about the fundamental theorem of calculus. So here's the question. How do you find the position of a particle at a particular time? Well, where you want to start is you want to start with the fundamental theorem of calculus. So I'm going to start there. I'm going to ignore the fact that we're talking about a position question for just a few seconds. Usually we see the fundamental theorem of calculus written in a different form, but I think it's important that you see it written this way and think of it written this way, right? F's the antiderivative of f prime, so the definite integral from a to b of f prime of x dx is equal to f of b minus f of a. And it doesn't take a whole lot of algebra to realize that we can get this expression from the fundamental theorem. This is what we're going to use to find the position of a particle at a particular time. The only way we can do that is if we know the velocity or have the velocity function. So we're really going to be using this form of the fundamental theorem. And I want you to kind of think about it like this. The f of a is a value that you know. It's an initial condition that they're going to give you. Hunt around for it. It's there. It has to be. This integral is net change, right? So if you take the value that you know, add how much it changed between the value that you know and the value you're trying to find. So this is the value that you want. You'll be able to get it. So the value that you want, in this case, the position at some time, is equal to a value that you know, some initial position, plus the net change, where you'd be integrating from A to B, where A is the x coordinate of the value that you know, and B is the coordinate for the value that you want, of the derivative function, which in this case would be velocity. So for example, let's apply this to the position function. What we had was f of b, which we're going to replace with x, our position function, is equal to f of a, again replacing that with x, plus the integral from a to b of v of t. Remembering that the velocity function is equal to the derivative of the position function. So this is really that same form of the fundamental theorem of calculus that I just showed you. So this comes from Form B of the 2007 AP Calculus AB exam. It was part of number 2. A particle moves along the x-axis so that its velocity at time t is greater than or equal to 0 is given by v of t equals the sine of t squared. The position of the particle at time t is x of t, and its position at time t equals 0 is x of 0 equals 5. And we want to find the position of the particle at time t equals 3. So what we want is the position of the particle at time t equals 3. The position that we know is the position at x equals 0. So using the fundamental theorem of calculus, if I add the net change between time 0 and time 3 of the velocity function, since velocity is equal to the derivative of the position function, this will give me the position that I want. So x of 0 is 5. From 0 to 3 of the sine of t squared dt, and that's going to give me the position that we want. Please note that this expression, that definite integral, even though it looks relatively simple, is not one that you'll be able to do by hand. Notice this was from number 2, so it was a calculator active question. So you'd want to use your calculator to evaluate this value. I believe if you evaluate this, you'll get something in the neighborhood of 5.773, I think. Well, that's it for questions. I appreciate everybody watching. I don't see that there are any additional questions being posted on YouTube with that hashtag. If you still have questions, remember that the AP Calculus exam is next week. If you want to tweet me questions still, I'm not going to do another office hours, but I might answer you with your question if you tweet me. You can use that hashtag, AskMoniqueKY, or tweet me directly, or have your teacher send an email, and I'm happy to answer the email for you. Coming up tomorrow is the AP Statistics office hours. So if you have any friends or neighbors who are taking AP Stats and wants to send some questions to me, tweet them to that same hashtag, have the teacher email them to me, or however you get those questions to me. If I don't get any questions, I'll just talk about preparation for the exam. The AP Statistics exam is in 2 weeks. On Thursday, we'll have an AP English Lit on Thursday at 8:30. So if you have questions for that, you should send questions, hashtag #AskTinaKY, and Tina Rose, our English director, will be running that one. And finally, on Sunday at 7 o'clock is the AP Bio Hangout. And if you have questions about the AP Bio exam, you should send questions to Lou at hashtag AskLouKY. I'm sorry, we already did English Lit. It's English Language. That's Thursday at 8:30. So good luck on the exam. Don't forget to get good night's sleep before the AP exam. Eat breakfast that morning. Be well prepared. Don't try to stay up all night. We don't want you to fall asleep during the exam. If you have any questions, feel free to tweet me. Bye.